Hello, YouTube! Welcome to my presentation on exponents. Okay, let's hop right in. So, many of you might not know what an exponent is, so let me just show you. So let's say you have the monomial x to the fourth. Now, what part here, or what main thing here, is the exponent? So, the exponent is actually this 4. And now, there's one other part. There's something called the base, and this x right here is what we call the base. Okay, so now you have some basic understandings, and now I'm going to introduce you to some properties. So first off is the zero exponent property, and this property states that any non-zero number raised to the 0th power is 1. So x to the 0th equals 1. And this is very powerful. If you're in algebra, you will use this. So I'll just do some examples. So x to the 0th, y to the 0th, 6 to the 0th, negative 6 to the 0th, all of them are equal to 1. Now let's get into negative exponent properties. So x to the negative n equals 1 over x to the n. And this means, let's say we have 6 to the negative second. That equals to 1 over 6 squared, which equals to 1 over 36. And let's say we have, 1 to the negative first power. That's just 1 over 1 to the first power, which is also 1. Let's just do one or two more examples. So let's just say we have negative 2 to the negative second power. That would equal to 1 over negative 2 to the second power, which equals to 1/4. Sorry if this is sort of messy. So the main thing to remember when you're raising exponents to the negative power is you take the base. Now this is the base, this whole thing. It includes all negative signs, and you take the base and you do 1 over the base, and then you raise the base to the power. So I'll just show. So 1 over base to the n, or whatever your exponent is. If you do that, you'll be right every time. Okay, so I hope you understand that, and now we're going to be introduced to some more properties of exponents that you'll use basically throughout your algebraic adventure. So I'm just going to erase some of this stuff because we need more room. Okay, so now I'm going to be talking about the multiplication property of exponents. So this says that if you have two common bases, now we know that the base, let's say we have x to the n, this is the base. So if you have two common bases, so let's just use our x example, x to the n times x to, let's say, the y, these are both numbers, you get your answer as x to the n plus y. And many of you are going to be like, what? What is he talking about now? But don't worry, it'll all be clear. So I'm going to do an example. So let's say we have 6 to the 7th times 6 to the 4th. This equals 6 to the 7 plus 4, or 6 to the 11. Now this is very powerful. Okay, so let's do a couple more examples. I'm not sure if that was proper grammar, but whatever. Let's say we have a to the 4th times b to the 5th times a to the 2nd. So remember, they have to be common bases. So which of these have common bases? Well, these two are the only ones that have common bases. So what we would do in that case was rewrite it as a to the 4th times a squared times b to the 5th. Now this is a to the 4 plus 2 times b to the 5th, a to the 6th times b to the 5th. And that's your answer. Because we can't simplify this because you have to have common bases. Okay, so I'm going to erase all that and we're going to do some more. Let me just zoom in here to give myself more room. Okay, so now what we're going to do is the power of a product property. So this property states that a power raised to another power equals the base raised to the product of the exponent. Now, this is more complicated than it seems. Say we have x to the n, and we have parentheses, and we raise that whole thing to the m. Well, that equals x to the m times n. Hopefully this makes more sense to you, and I'll show you why that is. So let's do a few example problems before I show you. So let's say you have 6 to the second, the whole thing raised to the third. Well, that would equal 6 to the 2 times 3, which equals 6 to the 6th. Now let's say you have negative numbers. Can you still do it? Well, sure you can. Let's say you have 6 to the negative second times 2 to the third power. That's just 6 to the negative 6th, and then remember, you have to do 1 over 6 to the 6th, because that was our last property. So I'm going to erase some of this, do maybe 1 or 2 more. Let's say you have negative 4 squared, that whole thing, to the 20th. Well, this equals negative 4 to the 2 times 20, or negative 4 to the 40th. And this is positive. This can just be written as 4 to the 40th. If you have a negative base, but your exponent is an even number, then you can just get rid of the negative sign, because they're going to cancel out, because a negative times a negative equals a positive. Anyway, okay, now I'll show you why that is. And that's more important here. Let's say we have 6 squared, that whole thing to the third. Now we got to think about what this is saying. This is saying I want 3 sets of 6 to the second, and I want to multiply those sets. So that would be simplified to 6 squared times 6 squared times 6 squared. And this just equals to 6 to the 2 plus 2 plus 2, which is 6 to the 6. So that's how that formula comes about. Okay, so now we're speeding through. I think we're almost done. Okay, now what we can do is, this is not really that important of a property, but I'll just show it to you guys. Power of a product property, it's another variation of it. So here's the words of it. A product raised to a power equals the product of each factor raised to that power. So I'll show an example. So a times b to the n equals a to the n times b to the n. This isn't really that important, so now I'll just do one example. 2 times 3 to the, let's say, third equals 2 to the third times 3 to the third. Now this is basically almost like distribution in a way, but I don't want you guys to start thinking that it's distribution. You sort of just push the exponent onto these two terms. So if you just think about it like that, you don't even need to memorize it. So now I'm going to erase this, and we're going to get to our final properties. Now we're on to our division properties of exponents. And basically this is if the quotient of two non-zero powers with the same base equals the base raised to the difference of the two exponents. So I'm just going to show you the equation, because you probably didn't understand that. Even I, when I started learning math, didn't get that. So a to the m over a to the n equals a to the m minus n. So now let me just do an example. 6 to the 7th over 6 to the 4th equals 6 to the 7 minus 4 equals 6 to the 3rd. I don't know. I'm running low on time. I think I'll just do one more. Let's say we have 5 to the 50th over, what should we do? Over 5 to the 60th. Now I'll show you this. This is 5 to the 50th minus 5 to the 50th minus 60, 5 to the negative 10, which equals 1 over 5 to the 10th. Okay. So, we're nearing the end. We're basically almost at the end. So now we have another positive power of a quotient. So this just says that a quotient raised to a positive power equals the quotient of each base raised to that power. So I'm just going to do this quickly. A over b to the n equals a to the n over b to the n. And if it's a over b to the negative n, this is b to the n over a to the n. Because there's a negative there, you flip the fraction. So I'll show an example of each. So let's say you have, what example should I choose? 3/5 to the 4th is equal to 3 to the 4th over 5 to the 4th, and 3/5 to the negative 4th equals 5 to the 4th over 3 to the 4th. So they're basically just reciprocals of each other. Okay, so we've covered a lot of ground. In the next video, I'll cover fractional exponents, which are a very important part of algebra. So now I'll just close with one last word. Subscribe, like, and comment if you like this and would like more videos. Thank you for listening. I hope you have a great day and ace that test.